f of x equals negative x plus 1 squared plus 4. Yes, however, be very careful. Let's write a big note here. Note. All transformations must be presented in the order of operations. So what do I mean by that? Let's say we are given this function and I ask you to evaluate it when x is 5. Which of all these operations you see here will you perform first? Right. So that's my first transformation. From the base function, this is the first transformation. So I get a number. I square it. What will be the next transformation? What do I have to do first? Let's say I have 5 plus 1 is 6. The square is 36. That's done. That's the function. What will be my next step in order of operations? By? Exactly. That's my second transformation. So I got 36 with minus 1 in front is negative 36. What do I do now to negative 36? Right. So this has to be, all transformations must be presented in the order of operations. So first, let's identify the base function, because without that, I can't continue. What is the base function used to determine this?
X squared.
Awesome. Perfect. So now, the first transformation in order of operations, what will you say it is? Again. The exponent is just the function. Don't worry about the exponent. That's the function. Very good. So the first transformation is this. I'm changing x into x plus 1. Where does this graph go? To the left. How many? Exactly. Very good. So this is left 1. Number 2 is a transformation on number 1, not on the base function. So let's take a look. What did we say the second step would be? Exactly. So on this, negative x plus 1 squared. Now I have to analyze. From this step till this step, am I changing x? If you say yes, then I have a reflection with respect to the y-axis. But if you say no, you're changing y, then I have a reflection with respect to the x-axis. Am I changing x?
No.
No. So what am I changing? So it's a reflection with respect to reflection, WRT, with respect to, oops, the x-axis. Number 3 is a transformation on number 2. Let's go back to the function. This is done already. So now I have to write negative x plus 1 squared plus 4. So what transformation is 3 on function from 2? Upward. An upshift. Now we're going to graph all of them. We are going to start with what? We're going to start with the base function always. Here it is. So this is our x squared. Then we continue with number 1, as you perfectly said. You already told me what to do. What do I do? Very good. Here it is. So here's my left 1, which is x plus 1 squared. Then you told me to do what to x plus 1 squared? Here it is. It shouldn't be this wide, I'm sorry. It has to be symmetric, forgive me. So this is negative x plus 1 squared. And then you told me to do what to this graph? Moving up 4. 1, 2, 3, 4. I'm going to move this point up here. So here's the graph. This graph, I'm just going to emphasize it so it's not confusing. This is the final graph of negative x plus 1 squared plus 4. Can anyone identify the vertex? I know you remember. We're going to talk about it again in chapter 3. Can anyone identify the vertex of this function? Of course, negative 1, 4. It's this point, the point of maximum in this case, negative 1, comma 4.
Isn't that kind of like an H and K?
Yes, it is in the H and K. That's exactly what it is. Negative 1, which is H, and K, which is 4. Exactly. So this was a combination of transformations. Ready to continue? Yes? Okay. So let's look at one more. We're going to look at the vertical stretching and shrinking. I would leave the last one for the next test. So that's where we're going to start with. So I'm just going to look at 5 right now. And then look at combinations with all of them. Ready? Any questions? Any questions? Okay. So we're going to look at, let's say, f of x equals 2, the absolute value of x, and g of x, then the other function, as 1/3 the absolute value of x. Again, the same question, which function was used to create f and g? Of course, again, we have the absolute value of x. You understand that if we don't know how the absolute value of x looks like, we're not going to be able to do anything with this, right? That's why we listed those 7 functions. Perfect. So let's graph and then analyze what happens here. So here is the square root of x. I'm sorry, you know what I mean, the absolute value of x. It's the v function. It bisects the first and the second quadrants. So this is the absolute value of x. So now let's discuss what happens here. First of all, I have to analyze whether I'm changing x or y. Because if I'm changing x, we will have to, that's transformation 6. So and if we're changing y, then we're going to do something else. So I don't want to combine those two because we didn't get to 6. So what am I changing? Clearly. Yes, this one has 1 in front, right? It has to have something. But that one, it has 2. So when x is 4, how much is the height? 1, 2, 3, 4. How much is the height? 4. But if I have 2 in front, and if I have 4 here, the absolute value of 4 is 4, but then 4 times, it will be a height of 8. So if this is 4, this will be a height of 8. What do you think happens to this graph from, exactly, and we call that a vertical stretching. The branches get closer when we multiply by 2. So this is the graph of twice the absolute value of x. This is called a vertical stretching. By a factor of what? Exactly. By a factor of 2. In other words, for any x value, this is the absolute value of x, and this is twice the absolute value of x. For any x value. Good, let's look at 1/3 x, the absolute value of x. What do I change? Do I change x or do I change y? Exactly. But what happens now? So if I have here 3 with 1, 3, 3. But what if I have 1/3 in front and x is 3? From the absolute value of x, where do I go? This way or this way? Right, because all heights now are divided by 3. So here's how I determine that. So this height is divided by 3. So here it is.
So if it's a fraction, it gets wider. And if it's like not
Exactly. Yes. Yes. So this is 1/3, the absolute value of x, and this is called a vertical shrinking. By a factor of, careful, very good, by a factor of 1/3. This will be the end of the material for test 1. So now I would like to look at combinations with all of these. So let's go back to the table and put in our findings for number 5. So if I change y into twice y, for example, what type of transformation is this? Vertical stretching by a factor of 2. And what if I change y into 1/2 y? Vertical shrinking by a factor of 1/2. Okay. So here's a combo. Y or f of x equals -2 the cube root of x plus 1 plus 4. First of all, which function was used to graph this? Do we all agree that this is the cube root of x? Let's graph it quickly because we know how it looks like. So here's the graph of the cube root of x. Very similar to the square root, but it's defined everywhere. It's a friendly function. No restrictions whatsoever. The domain, all real numbers. Okay. Now remember, the transformations have to be in the order of operations. What is the first step? Indeed, the cube root of x plus 1. That is indeed the first step. So the cube root of x plus 1. What do I change? Because if you say y, then it's up and down. If you say x, it's left and right. So what is it? Left 1. When we change x into x plus 1, it's left 1. Number 2 is on transformation on this. And I have to caution you on something. So if I want to evaluate f of x at 5, I will say 5 times plus 1, take the cube root, and then multiply by -2, and then add 4. However, I have to separate, because these are two transformations. Multiplying by 2 will do one thing. Multiplying by -1 will do something else. So number 2 for now is only 2, the cube root of x plus 1. Number 3 will be, can anyone dictate number 3? -2, the cube root of x plus 1. We'll come back and explain what those are. And the last one will be -2, the cube root of x plus 1 plus 4. So let's go back to number 2. We did not write what number 2 represents. Am I changing x? No, we haven't discussed that one. I'm changing y. So what happens? Yes, a vertical stretching by a factor of, so vertical stretching. Okay, now number 3 is a transformation on number 2. I see cell phones, and then I can have a question and ask you to do something for me. Okay, so -2, the cube root of x plus 1 is a transformation on 2. What type? Am I changing x? If I'm changing x, then I'm doing this. Bless you. If I'm changing y, then I'm doing this. I'm changing y. It's outside. It doesn't touch x, right? So it's a reflection with respect to, indeed. So now number 4 is a transformation on number 3. What does number 4 do to number 3? Indeed, upward. So we do have this cube root of x. The first step you told me to shift it 1 to the left. I'm going to do just that. A little exaggerating, it shouldn't be that high. So this is the cube root of x plus 1. Then you told me to stretch it vertically. Okay, so this is higher and this is lower. So this graph is twice the cube root of x plus 1. Then you told me to do what? To number 2 to get number 3. Right. This piece goes here. This piece goes here. So this graph is negative 2, the cube root of x plus 1. Final step. What do I do to this graph? Indeed. So 1, 2, 1, 2, 3, 4. So here's the graph at this point. So this is final. So negative 2, the cube root of x plus 1, and outside plus 4. Now let's choose whatever you want. We are on page, yes, questions?
So if it was a reflection in the y-axis, would it be like negative 2x?
Negative x inside.
Okay.
The negative will touch x.
Okay.
But it doesn't touch x, it's completely outside, will be y.
Yeah.
Okay, so let me just give you an example. Here's an example for you, which is an application of transformations. So let's say we have data and we measure the height of each kid when he is 10 months old, 20, 30, 40, 50, 60. Can anyone give us an idea of what function would you try to fit? Exactly. Not x squared, not the absolute value of x, not the cube root because there is nothing on this side, and so on and so forth. Only because we know how the square root looks like. Okay, so please choose any problem you would like to work on. Although, remember, we have not finished. There is one transformation that we will leave for next time. So on page 294, from 1 through 118. And I will make the 294, 295. If you choose something that has transformation number 6, we will find another. Okay, so what I would like to work on is a graph that is given to us. So I'm looking at problems 45 through 52. Let's take a look. And let's say 48. We cannot do anything before we copy the graph. Very easy graph. So negative 4, 2. We are given all these points. Negative 4, 2. Then I see negative 2, 0. Then I see 1, 2. And this is connected. And then I see 2, 2. And this is connected. And then I see 4, 0. And this is connected. So we are given this function. What type of function is it, by the way? Say it again. Careful. We graphed on one at the beginning of the class today. Of course. It's defined in 3 different pieces. This is a line on negative infinity to 0. This is another line on and this is another line from 2 to 4, right? Indeed, piecewise defined function. In problem 48, we're asked to graph the function g of x, which is negative f of x plus 1, and then minus 1. Nice. So now we don't have any basic function here. This is the basic function. So we don't think of in terms of those 7 functions we graph. So in order to graph g of x, given f, what will be the first transformation in order of operations? Right, I have to graph f of x plus 1. Good. Perfect. That's the first step. F of x plus 1, and you said already that this is we changed x into x plus 1. So maybe I should write that this is f of x so we know. We changed x into x plus 1, left 1. Number 2 is a transformation on number 1. What is it? Perfect. Now I'm asking myself again, is it a transformation in x? If it is in x, then it's with respect to the y-axis. If it is in y, then it's with respect to the x-axis. Yes, because the negative sign does not touch x. It's completely outside. So this is a reflection with respect to the x-axis. Perfect. And this is the last one, which is a transformation on 2. Negative f of x plus 1 minus 1. What does 3 do to function from 2? Down 1. Do you agree? Okay. So this is indeed down 1. So now let's graph. First, you told me to shift this graph 1 unit to the left. I'm going to do just that. This is negative 4, negative 2. It will go to this point, 1 to the left. This point will be moved 1 to the left. This point will be moved 1 to the left. This point will be moved 1 to the left. And this point will be moved 1 to the left. And this is which function? Of course, it's on the same, but I just want you to see it, so that's why it's the same horizontal line. So what is this green function then? Do we all agree with f of x plus 1? Then you told me to take this green graph and reflect it with respect to the x-axis. So here's what we do next. This is at negative 2. Where does it go? Negative 2. Where does it go? Exactly right here. This point is at 0. Where does it go? Exactly, does not change. This point is at 2. Where will it go? Right here. This point is at 2. When x is 1, y is 2. Where will it go? Very good, awesome, right here. And the last one has a height of 0. Where will it go? Nowhere. So this is the graph. Which function is this again? Final step, please, of this. Move it down 1. So this height, because it's a transformation in y, this height is at 2, height of 2. Where does it go? This height is at 0. Where does it go? This height is at negative 2. Where does it go? This height is at negative 2. Where does this go? That point goes here. And this height is at 0. Where will it go? This, I missed it a little bit, sorry, is the final graph. Final, negative f of x plus 1 minus 1. We were able to do this because we understood transformations. This is not a basic function. This is a piecewise defined function, but we were able to go through all these steps using the order of operations, and we're able to graph negative f of x plus 1 minus 1. Very good. I think we should start the review unless you want to work on more types of problems. Can we start the review? Yes? Okay, so let's start that. I forgot to get myself a copy, forgive me. So do you have the copy?
I'm not sure.
You do have an extra? Oh, yes, I did. I gave you 2 last time. Thank you. I'll give it back to you, I promise. So I don't waste your time. Yes?
Yeah, I need one.
I need one too.
They were given last time. You have it.
I was in here last class.
Oh, you were not here.
Rather was
Oh. Thank you. Here it is. 1. Here's the second one. And you can get this, you can take this back. I just found enough. Good. So everyone else has it? Yes? Okay, let's start. So you choose what you want to start with. I'm fine, anything, or if you want to use the order they are presented in, I'm fine with that too, whatever. Say it again? Good. So let's do them in order. So which page am I on? 16, 12, 13, 13. Okay, so we have 2 over x plus 3 over x minus 4 equals 21 over x plus 3 times x minus 4. So let me just say one thing. I will write something similar to this because you've been using my math lab and I think this will help you in the long run. I don't want you to write anything here. Not interested. This is not what I grade. So everything you will get scratch paper and you will present all your work here. If you want to read this, it's fine. If you want to fill it in, fine. But no credit will be given for work here. Everything has to be on scratch paper. And I will have instructions for you to remind you what to do. Okay? Good. So the question is asking us to, this is a rational equation, and we're asked to solve it. Yes, please.
I have to leave early. Is there any way we can do number 8 after this one?
Yes, we'll do number 8. And I will not see you tonight?
No, unfortunately.
Okay, that's okay. Good. So it's a rational equation, and what do I do? Yes, I recommend 2 over x plus 3 plus 3 over x minus 4 minus 21 over x plus 3 x minus 4 equals 0. If I forget the equal symbol and 0, then I'm in trouble. Then the next step would be
What is it?
correct, restrictions. Restrictions on x, very important because it's a rational equation. So what do I write?
It can't be 0
What?
It can't be.
at negative 3.
No, x can be 0. 0 plus 3 division by 3 is fine.
It cannot be negative 3 or 4.
Cannot be negative 3. It cannot be 4. Is that clear? Everyone? Good. So what is the next step then?
Multiply each side by x.
Nope. We find the least common denominator. You can use that method. Is acceptable. What is the least common denominator? Very good. All different factors I see. And this is the product. What does the top of the first fraction need? The second and the third. Very good. Very good. Very good. Now please give me the numerator.
2x minus 8
2x minus 8, perfect.
plus 3x plus 9
Plus 3x plus 9, perfect.
minus 20.
Minus 21, awesome. Do we agree with this? Everyone? Good. So please combine like terms and tell me what to write. 5x. So this indeed is positive 1, indeed. So minus 20 divided by x plus 3, x minus 4 equals, again, if you're using my method, what do I have to write?
0 over 1.
0 over 1. This is a reminder that I managed to change that complicated rational expression into a proportion in which I can cross multiply. Very good. So what do we get? So I have to show that. So I have 5x minus 20, which is this, must equal. Very good. I add 20. It's a linear equation. I get x equals 4. It's a big question mark because I stated restrictions and I have to check against the restrictions. That's why I wrote them. If I don't check, I may miss something very important. Okay, so what do we conclude? Indeed. Indeed. Let's look at number 8 and then we'll come back. Number 8. Very good. So in number 8 we have x to the 4th minus 5x squared plus 4 equals 0. Of course I will read, this is helping us by reading the requirements, right? So I highly recommend read the requirements. It will give you a hint and it will tell you what to do next. Yes, substitution. So what will you substitute? You will say let y be. Very good. So this is y, but only if, otherwise it doesn't work, only if this is, which one? I cannot have x and y in the same problem. So if I replace this by y,
Let me be let y equal y squared.
so what will this be?
That'll be x squared.
Very good. Is that true? Yes. When I square x squared, I get x to the 4th. Of course. Can anyone dictate the new equation, please? Y squared minus 5y plus 4 equals 0. Very good. What type of equation is it? What type of equation is it? Very good. How do we solve it? What is the easiest way? Good. So which is?
Y minus 4 y minus 1.
Very good. So then we have two solutions in y. What are those solutions in y?
4 and 1.
Very good. 1 and 4, 4 and 1 doesn't matter. But this is a new equation. And this is a new equation. Which equation? Very good. Now, how do I solve these two? And I should have asked, by the way, from the very beginning, how many solutions do we have to have?
4.
Very good. So then this is a reminder. Because if I only get 2, I'll say, oops, something is wrong. So which method is typical here? Taking square root. Very good. Awesome. So this will be x equals. Very good. Do not forget, we have to have 4 solutions, and this one is. That's it. And we do have 4 solutions. Any questions? Any questions? Okay, 4 more minutes. Yes, please.
If I solve it in a different method, do I still need the plus or minus?
Yes, as
Because
long as.
the way I do it, I just get minus 4 plus 4 minus, or I guess minus 2 plus 2 minus 1 plus.
Yes. So instead of taking the square root on both sides, you moved 1 to the other side and you factored. But you will still get plus or minus
Yeah,
1.
I should,
Well,
or
that's
if I
fine.
just write it all out.
No, at this stage, you can do whatever you want.
Alright,
You
it's
use
done.
the substitution to solve it as the problem is requiring us, and now you can take the square root or use factoring.
Because I know for my math lab, they require you to do the plus or minus, or that the hard way.
Right, but this is much easier to take the square root. Then move on, factor.
No, well, so what I did is I just, some of the ones that are, I guess, easier to factor, I just
That's
make
fine.
it do 4 different.
But this is a typical situation when taking square roots. But whatever works for you. Okay, let's look at number 2. Solve the equation by the square root property. So 5x plus 7 squared equals 90. Yes, that's fine. We have 3 more minutes. Okay, so first step. Careful. First step.
Divide by 5.
Yes. I have to clean it up. Always look at the equation and say, is there a way of simplifying it? And there is. Yes, we will divide both sides by 5. This is a requirement. So this is x plus 7 squared. The 90 divided by 5 is? Perfect. Now, this would be a mistake if you would expand and move 18 and try to factor. It's not factorable. So that's why this method is extremely useful. Which method? Taking the square root from both sides. Awesome. Very good. Well done. But remember, from the very beginning, how many solutions do we have to get? 2 indeed. So you will write x plus 7 equals. Careful.
Plus minus.
Thank you. And now the square root of 18 has to be split into 9 and 2. The square root of 9 is 3. And the square root of 2 cannot be changed. Final simplified form will be x equals. Very good. -7 plus or minus the square root. Okay, 1 minute. Let's work on number 4 or number 3. Complete the square, whatever you want.
Number 3.
Which one?
3.
So we want to look at 3. By complete the square. Last one. So this is x squared minus 6x equals -2. We are specifically told to solve this equation using completing the square. The method of completing the square says, number 1, I have to identify the middle coefficient. Please divide it by 2.
3.
Negative. And then square -3. 9. This is what we need. X squared minus 6x plus 9 equals 9 minus 2. And notice that 9 must be on both sides. The left-hand side now is already completed. The square is completed. The right-hand side is 7. So what do I have to have here such that when I square it, I get those 3 terms? First day of classes.
X minus 3.
Very good. And final step.
Square root
X minus 3 equals.
plus or minus 37.
And finally,
X equals 3 plus minus 37.
thank you so much for staying those